Okay, so essentially we are talking about definition of quality and how quality needs to be properly defined in the first place. Okay, and I think the issue now with a lot of things in construction is because we have a lot of like a ripple or what we have referencing to the manufacturing industry. You see, and because of that, the way that we adopt the system of managing quality, it is kind of difficult, for us to adjust and function within that system. So because I've mentioned just now in the previous recording that because manufacturing is a different kind of environment as compared to it's a completely different kind of environment as compared to um, uh, construction industry or the civil engineering industry. So essentially, they are more controlled. Their environment are more controlled. Their environment are considered a lot more rigid, and depending on what you're manufacturing, is actually very very tightly controlled even. So the people that goes into it, the machines and all that, they are all we in control, you see. So when we come to construction, it's a more freer, open kind of environment. So the system that we apply, if we go back to the history of quality and quality management and all that, we will realize that if we just directly adopt the systems into the in construction industry without actually um, changing anything or without actually improving anything or without actually amending anything, it can be very, very difficult for us to adopt because that environment, is designed for that particular environment. And then we just take it and use it for our more open environment. We're definitely going to get issues. We're going to get issues. Maybe it's not because the actual product is actually no good, um, but um, it's actually the environment that doesn't allow you to achieve that kind of level of quality, you see. So, and like, for example, ISO, okay, ISO is more, is people take it as, uh, 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 a quality management, I mean, they take it as a product, they take it as a standard, and in a more rigid environment, it's actually a lot more easier to do that. See, so but when it comes to ISO going into manufacturing, you will realize that it does not apply that well, and people take it as a standard. They take it as something to follow completely, for quality to be met, to be achieved. You see, and how could that be right when you don't even, I mean, when the thing that you're using as the measurement, when the thing that you're using as a definition is actually not even suitable for your industry or for your product or your facilities, you see? So I have to be very emphasizing on the ISO thing because ISO is something that everybody talks about, and when it comes to quality, now we don't even have ISO. It's about 2000 something something already, or 2020 something something. So we're in the era of 2000 something something. So 2020 something. So we have to be very careful when we are using ISO as the final system, to look into the quality of our product. And of product means our product as a construction product, huh? And I think this is something for us to be very aware of, not to take it as ultimate. Actually, quality, ISO is a standard, and it's actually just management processes, procedures, it's a documentation processes. So it doesn't consider too much of a human resources consideration, and it's pretty much applicable to manufacturing industries only, and then we take it and apply it to our construction industry. It will be difficult, I won't say it's a disaster, but it'll be difficult to achieve. So when you're setting something that you can't achieve in the first place, the achievement of it is already out of the window already. So all your processes, no matter what you do, you want to achieve it, it's not going to be easy. So we should be talking about quality based on construction industry. So we should be talking about it's okay to have ISO. It's okay to look into the documentation processes. It's fine. We can take the good bit of it, we don't take everything. And there are many other processes in construction industry that our system concentrate on quality control, such as ITP, such as ITP is testing plan, PQP, project quality plan. And we talk about having this sort of things as a system, and how effective are all these systems, the performance criteria, specs, specification, following the specs, how good is it for the construction industry? We have all these tools actually from the construction industry. I mean, if you can do research into QA/QC methods or processes, these are the things that will crop up. See, so and we do understand the importance of quality, because quality costs money. In the end, the typical PAF, meaning that the PAF systems will say that quality is not for free, because you have prevention costs. Okay. If you don't do it, you need to prevent it. There's cost of prevention, appraisal costs, audits, our verifications and all that, internal costs of failure. Failure is internal and external cost of failure. So these are the costs of quality. So if let's say quality fell, or if you don't do certain things and then affects the quality, PAF is the quality cost. So we usually cover the cost of quality based on these three elements. And within failure is something that we always calculate. It's easier for us to calculate because it's very clear. It's very easy to understand. So internal, external failure cost. The P and A is the one that is a little bit harder to define, because if let's say it doesn't happen, you have prevention costs, you have got appraisal costs. These are all costs, you see. So if this cost going to be a lot lower, then if it happens, there's a failure cost. So you need to find a balance. Does all happen all at the same time? You've done some prevention, you've done some appraisal, and yet it fell. So what is the cost of quality? So doing quality management is not cheap. Not doing it is also, looking at doing it, and it's not cheap, but not doing it is also not cheap. So which one is cheaper? So this is the kind of mentality that we must have when it comes to quality. We must realize that we don't do it, there is a cost. We do it, there is a cost. But which one is cheaper? Okay? Which risk would you be taking? Which kind of level of risk will you be taking? So it's very important for us to set up a system, a proper system. So we talk about QMS system, quality management system. That quality management systems will comprise of QA, QP, QA, QC, which we will talk about in subsequent recordings. So QP, QA, QC, so we can take the manufacturing systems and apply that. Yes, it's a system, but how suitable is a system? We have new, very construction-based kind of systems like PQP, ITP, testing plans and all that. So internal testing plans, and project testing plans, and they talk about different volume of work. You must have different testings, like for example concrete, for example tiles, for example paint. So different kind of system. How effective it has been. So, but if we talk about cases of quality failures, cases of PAF, we will realize that PAF has not really reduced with all these systems. So has this system been effective? Can we create our own systems for our own project? And how important it is to create our own system? How important it is tailor-make our own QMS with the QA, QP, QC, taking references with the current existing QA, QC or QMS systems and applying it to quality. You see, so I think that is something worth looking at, especially for master's level. It's about creating your own systems, understanding QP, QA, QC at the very elemental level, the very foundational elemental level, and do creation of your own system. That is wonderful, I think. So with that, we will move into QMS. What is quality management system? It's about a system that can plan quality, manage quality, and control quality, and they work well together. QMS system, different QMS systems, quality management, we've gone through different eras as well. You can read through it here. Okay. And then, so then with this, we move into, you can see the changing, the improvements, of the systems that create our new current QMS. Okay.